Just like yesterday class, we're gonna review from foundations, which I should have done a while ago. This is not the end all be all of your studies. You need to start from here. If there is a puzzle piece missing from here, if you do not know one of these equations, you're kind of hosed. Now, I'm not saying that everyone has got to be perfect, but you need to at least know that this equation exists relating this, that, the other concept. If you don't know that it exists, how are you going to look it up on your equation sheet? If you know that it exists and need to refresh yourself, sure. But this should, all of today's lecture should be stuff that you know every puzzle piece. You're free to use the equation sheet that you should have already been writing or have produced. There are only a couple of equations for energy. There are some more equations for rotation. We're going to visit each of the foundational pieces, apply them briefly. If you can do this, this is your jumping off point to go to the harder problems. I am posting, by the way, the previous midterms. I am posting against my better judgment. I'm posting the the practice final that y'all are doing in the lab. Lab is still not optional. I'm not going to post it until after the labs are done. I'm also posting the key for that against my better judgment. Against my better judgment, because I'd really like to make it so that if you skip lab, you're missing the opportunity to learn when you're missing the opportunity to learn. You know that. But whatever, I'll post it because I'm a pushover. Too much. Some other administrative thing. I will probably remember this at the end and squeeze it in, but let's go. Okay, so Google. Does anyone have any administrative questions about stuff? Please.
Are you gonna listen on your side?
Do you want additional one more homework? I can. Who wants an additional homework that's a review, that's a smattering of questions, or who's happy with what you got? Okay, so raise your hand if you want additional homework. Raise it high so I can actually see.
Yeah.
No. If I'm putting it up, you should do it. It won't be like 80,000 questions. You do a sampling like 25 questions. Okay, but there will be one, it'll be due by next Friday. Does that sound fair? Next Friday. So you can do it at any time. I'll probably post it tomorrow. I should have done this and decided on this before. You may always have an equation sheet, and Merry Christmas, you could have a full sheet for the final. I was pushing you guys to compactify your stuff for the midterms, so now you don't have, if you transfer that over, it won't be ridiculous. Full piece of paper front and back. Thank you for reminding me on that person. Thank you for pointing it out. Other questions? I cannot, since the 3 o'clock class is taking their exam after all y'all, I cannot give the answers to the final immediately after class, just FYI. I will post the answer key, the question paper and answer key after they take theirs for anybody who's interested, but sticking around is, you can stick around to complain. Yeah. Okay, anyway, ready, set, let's get into this. Instead of just talk about what I'm going to talk about, let's actually talk about it. Show me that you know stuff. W is what if we're talking about energy? Yeah, K is what if we're talking about energy? That's right. Again, please pay attention to the context. Not talking about weight. Give me the equation relating these terms in this context. And I'm not looking for their names. If I say foundational equations, you should tell me the equation. I'm hungry. It's like delicious food. Or maybe you're just a vampire and you're suddenly aware of it. Or maybe you transitioned into a vampire and you're suddenly aware of all the lighting. The fruit vampire is finally not. A fruit vampire? My internet connection was not the only thing. Okay, 10 more seconds. Show me what you got. Have we talked about E equals MC squared at all? No, just no. Gesundheit. Okay, I'm gonna say that time's up. If you know these, you know them. And if it took 5 minutes to look up, you don't really know them. Go over each one. And then flashcards, baby. This is the start of your studies. You need to know vocab words before you can learn to speak. You need to know the central core definitional equations. Too many people are screwing up the meaning of cos theta. So I'm gonna, instead of writing cos theta, let me write this as +1, -1, 0. If what? If helping. If hindering, does everyone know what I mean by hindering? I've been using this word the entire semester. You are hindering something, you are opposing it, you are the opposite of helping. So force times displacement times positive, negative, 1 or 0, depending on what that force is doing for that displacement. Oh. Einstein. And in lightning review, again, work is force times, really, if I'm talking about magnitudes, distance moved times a positive, negative, or zero factor, depending on what that force is doing for that displacement. Kinetic energy K is half mass times speed squared. Gravitational potential energy is your weight mg times the height you are sitting at relative to some origin, which must be internally consistent through the problem. Elastic or spring potential energy is half spring constant times the change in length of the spring squared. And the foundational, central, fundamental core equation of all of energy land that you can do every single problem that's not just asking for a subpart, right? Not just asking you pure plug-in numbers. You could do absolutely any problem by considering the change in the total energy of something equals the total work done on that by forces not included in the energy band. Now let's apply these 5 different ways from Sunday. By the way, I have actually finally remembered to post PDF of the lecture notes from Monday on the slide section of Canvas. I will do that with this section, these lecture notes as well. And yes, so you do not need to write down every single line. Okay, these guys are straightforward. These are plug and chug. You know them or you don't. So I'm going to give you like 2 minutes to do 2 problems. Ready, set, chop. Oh, not A and B now. These are F and G. Okay, time's up. Here we go. Force times distance, baby. You want work? You got force, you got distance. 12,000 times 5 times, is this force helping or hindering? You're going down. You're going down, son. The tension is pulling up. Ri, da, see? Did it, da, da, did it?
Right.
Well, if you're going to say that 5 is negative, then you wouldn't also count a factor of cosine theta. You could say magnitude of force, magnitude of just distance times +1 -1 0, but don't do both. Yeah. No, no. If you want the work done by tension, you don't need to care about the weight of the elevator. If you got the force of tension and you got the displacement, that's all you need to calculate work. No, if I say T, I mean tension. If you use net force, you'll get net work. I asked the work of the tension, not the net work. You're absolutely right. You can calculate the work done by any force. You can calculate the work done by every force. You have to look. I hope everyone's paying attention, by the way. This is a really important question. What force do you use to calculate work? I may totally give you a question like this, where I may totally give you a question where I ask you the work done, the net work done by all forces. And every case you have to look the work of what force. If I ask for the work done by tension, use tension force. If I ask you the work done the net work, then you use the net force. Yeah. Please. Yes. If I say the work done by every force acting on the object. Well, also you have to remember that people will be changing kinetic. If you talk about the work done by every force, there are no tension. To have it'll be squared. But I digress. Yes, is the answer to your question. So the final answer, negative what? 60,000 joules, not newtons. Work is not newtons. Okie dokie, pokey pony. Okay, if a billiard ball is moving at 5 meters per second, I can find kinetic energy with my good old trusty equation, half m v squared. Questions about kinetic energy here? Most students I have found, and based on my dim recollection of having learned this in 1997, 8, say that work is approximately 1,000 times harder than kinetic energy, though. Yeah. Conceptually. Okay, please. All energies are joules, including the transfer of energy, which is work. Okay, here's 2 more. Make it a little more sophisticated. The more sophisticated here in C, I will just tell you, I am going to tell you some things that you do not need to multiply and divide by. I'm doing this so that you have to think about what am I doing and what do I actually need to use. That you're not just randomly multiplying and dividing things. Yes, there are numbers that you don't need. Okay, take 2 minutes, 30 seconds. Thank you. Well, HI. Yo. Yep. Let me encourage you to read the question that is asked. Change in gravitational potential energy. Don't tell me about a spring constant in the first part. What is energy measured in? Always, always, always joules. In the second part, you can tell me about newtons per meter. I'm asking for what is the effective spring constant? I'm going to give you a little more time. Only 30 responses yet. Okay, time's up. Give me your best shot. Fire away. Okay, first one. Gravitational potential energy. What's gravitational potential energy? MGY, MGH, whatever. What's H? What's it mean? Height. In particular, I asked for the change in the potential energy, so I'd use the change in the height is, what's my weight? So what do I plug in for M? Well, I would, instead of dividing 650 by 9.8 to get M, and then multiplying it back by 9.8 to get mg, I would recognize that mg is weight, so I could just plug in 650. Again, I want to emphasize that if you are given weight, you cannot plug in weight for M. Weight is not M. Weight is W. Mass, weight. Do not flip those two. And then you don't need to find mass and then just multiply back again to get M times G times H. It's not wrong if you do, it's just silly. Okay, now for I, we have to apply the principles of energy in addition to just plugging in. What form or forms of energy do I start with at the top of the mountain? I hope you realize that at the top of a very high thing, I have gravitational potential energy. Also, I just calculated that gravitational potential energy. Am I moving at the highest point? No, I just stepped off the cliff. Gravity has had no time to accelerate me. So I have no kinetic energy at the beginning. Do I have spring energy at the beginning? No. So my initial energy is purely 195,000 gravitational potential. At the end, am I moving at the lowest point of my motion? Lowest point of my trip? No. If I'm at the lowest point, I'm not going down. If I'm going down, I move further down later. And they're not moving out because it's not gonna go out and lower. At your lowest point, at your turnaround point, your velocity is permanently zero. Okay? Turning points, v equals zero in one dimension. Okay, so kinetic energy is zero. Am I up? I think compared to 300 meters, I don't actually really care if that 1.5 meters is at, dipping down to here's the 1.5 meters below the trampoline surface, or to say if the trampoline surface is at ground level and they dug a hole underneath it. I don't care. 1.5 is so much less than 300. I'm just going to say no gravitational. Yeah, you buy that? So you're not up. There's no gravitational energy. You're not moving. There's no kinetic energy. Your final form of energy is purely spring energy. Now, the last question I ask thee, is there work done by forces unaccounted for? What forces act during this whole event? There's weight force. There's a trampoline exerting spring force. That's it, baby. So there is no external work. What could we say? Delta E equals zero. Change in energy equals external work becomes energy final, UE final, minus energy initial, UG initial equals zero. Oh my God, what's the final spring energy? It must be equal to the initial gravitational potential energy. Write down 195,000 equals 1/2 K times 1.5 squared. Solve. You get something rather impressively large. And it's 73,000 newtons per meter. It's quite a stiff spring. Trampoline. Now, a whole bunch of people didn't get that. So I think this is where we have you turn to your neighbor and discuss the process that I just said, because every single step in here is something that'll pop up in the third of the test that's energy. Turn to your neighbor and discuss the reasoning, and then ask me a question or two.
For this one, I'd use a picture of the formulas.
Sorry?
I would say, because in my head, I thought it was.
Well, you don't have spring energy given. You know the gravitational sometimes. It takes a step of reasoning to realize that that initial gravitational energy becomes spring energy.
Yeah, this is the way I write it. So. Well, because I have one.
Did you know what?
I've been writing down this equation.
Yeah.
Like trying to comprehend it.
Yeah. Here's the. I flipped them. This is gravitational energy becomes spring energy. To reverse order. Whatever.
It's fine.
Here's the spring energy equation. Half K squared. Half K till that squared.
Well, because I only did that one, but I assumed that K was so.
That's kinetic energy. No. This is K is the spring constant of this equation. Half Kx squared. What does this K mean? This is the spring constant. That's what I'm asking for.
Yeah, what I did is I plugged that in, but that's wrong, so. I was just trying to.
Know what each letter means. Half K squared, K is the spring constant, X is the displacement, the change in spring length. Okay, ask me a question or two. And learn from each other's questions, by the way. Where is this hard? Where did you drop this question? When I explained it, what part didn't make sense?
Kind of that middle section where you can see that, like section I.
Okay, so can you tell me about the change in energy? What forms did we have? What forms did they become? So
PHY was, gravitational.
Yep. Yep, gravitational potential.
And actually go down to the mass force,
That's right.
because it transforms energy into bigger function.
That's right. Not just it's not created and destroyed, it's not created and destroyed, and there's no external force that we have to account for. Good. Sounds perfect. Another question. Only like a quarter of you all got this right. So ask me, yes.
Is the 1/2 K times that's the formula we were.
That's spring energy.
The equals the 190.
That's what we just solved is the gravitational energy.
So for the bar, like equally what it's together.
Because gravity became spring. You started up, you end compressed. Sure. Wait, compression, the compressing spring is what I mean by elastic energy. Elastic energy is spring energy, is K squared, half K squared. Elastic is spring. No, you don't like it. Ask, keep asking, keep asking.
I think my brain needs to comprehend it. Like there's nothing to ask, just my brain just needs to comprehend it.
Again. The steps. What do we start with? We're up, so gravity, gravitational potential. What do we end with? We're compressing a trampoline, so spring energy. The change in energy is the final form minus the initial form.
Yeah.
There's no external work done by forces we haven't accounted for.
Okay.
W is 0. You don't like that.
Well, I understand why, because there is no external, so force based on external 0.
Yeah.
So.
There's no forces other than spring and weight, which is accounted for.
So
Spring force and weight force are hidden inside there. If we put the work done by them, we'd be double counting their effects.
Okay.
It's not that there are no forces, it's that every force that does work has already been condensed into a potential energy. Okay, so you're comfortable with this side, you're comfortable with this side. If I solve this algebraically, I add UGI to both sides. I get this energy becomes this energy. They're equal. Well, I ask you for a spring constant and it's in the energy chapter. So you should think, what is the spring energy equation? Oh, it's got spring constant inside it. Do you know the spring energy equation, half K squared? Okay, so you recognize that there's spring constant is K. So you can say half Kx squared equals what I just solved for as the previous gravitation. That's the step that's breaking.
Yeah.
I
Okay.
understand it much better after
Good. Okay, so we've got gravitational potential energy equals 195,000 from the previous problem. 195? Yeah. We have an unknown elastic potential energy of 1/2 K times however much the spring is stretched squared.
Okay, wait.
If these are equal, 195,000 equals 1/2 the unknown that I want. And I know delta x is 1.5 because I told you. Solve a get K. You like it better? Great. Other people, again, only about a quarter of y'all get this right, so I know that there must be more questions, please. Please.
It's 195. So when I jump up, I start at 150. The moment I hit sample, press that, I get that density to Is there an example of a fiction that, well, an example of a word yeah, where the total treatment is zero?
Sure. Suppose there's a friction force too. You're jumping into the trampoline, but I don't know, the trampoline's in a bucket of water. And I'll just tell you, the average drag water friction force is 50,000 newtons or whatever. I don't know. If there's another force that's not already included, springy forces, weighty forces, then yeah, you need to include an extra number.
How would that?
Calculate the force times distance. That's the work done. That goes here.
How to make that extra person at the end instead of zero?
Force times distance is work. Yeah, the work of that. Precise.
Yeah, well, where the zero is.
Yeah, work is zero if there are no other unaccounted for forces. If work is, I don't know, 100,000, zero would not be zero, it would be 100,000.
So we'll change the spring constant. Would it still be? That's possible.
Well, the 195,000 was the gravitational potential energy. If you didn't change where you started from or your weight, that doesn't change. And spring energy is spring energy is spring energy is half kx squared. That doesn't change. The value of k, if you have a different right-hand side on this, the value of k will be different if you have a different equation. But you do not need to change this, and you do not need to change this. You would simply have minus 100,000. No. Let's do this. Let's do this. Suppose I introduce a work of 100,000 joules, negative 100,000 joules. The friction is going to suck that out. I would say the final elastic energy minus the initial gravitational energy equals the external work done. I calculated that gravitational energy starts at 195,000. I just told you the work done by friction is, did I just say 100,000? I can add 195 to both sides and say half K 1.5 squared equals what? 95,000? That's what delta means.
That first.
You could have plugged in spring constant equation at any point. If two things are equal algebraically, you could substitute it before or after. Doesn't matter. So any algebraic legal steps will get the correct answer. Don't break laws of algebra. Please. If we talk about it as work, then if we talk about it as an external force, then we talk about it as a work. But once we introduce the idea of spring potential energy is the work done by the trampolines. So don't do work and the same force and potential energy. Pick one.
That a person has a gravitational potential energy then will bring energy. The way it's same magnitude is kind of like this.
Energies aren't forces.
But I kind of look at them like they have their.
They don't have direction at all, ever. Work can be negative. That doesn't mean that work is downness, as downitude. the minus sign on the left side of that equation does not refer to total down. Delta, the meaning of delta is change is final minus initial. I'm not adding together one thing up, one thing down. I'm subtracting a total from a total. Good questions. Other questions? These are good. Feel like these are helping people make breakthroughs. I hope y'all are listening to and thinking about what they're saying. Yeah? Yeah? Just to make sure, Wext is any force that is not included in, well, any work done by a force not already in the energies. Yes. Did y'all see that question? Wext is the work done by those external forces, not the forces themselves. You can't add a force to an energy. Force and energy are different things, but you can calculate the work those forces do and set that equal. Yeah. Well, work is not normal force, friction, or anything. It is the plug that into the work formula, force times displacement with a plus minus sign. Work is not force. Let me go up here. Work is not force. Calculate the work that the force does, and then yes. Great. Move on. Come on, let's zoom out if we can. There we go. I'm going to come back to this. Here's another equation that helps you combine energy with stuffity stuff, but I don't want to run out of time to do rotation. So here we go. Just fill this out, and then we'll come back. JKLMN, whatever. JK, LOL. And please pay attention. Period versus frequency. Omega versus frequency, in terms of this, that, or the other quantity, yeah? This is centripetal acceleration. Oh, I said. Okay, 2 minutes. You sort of know these or you don't. Oof, my eyeballs. Not many answers here. Who wants another minute? Okay. Gesundheit back there. Okay, I'm gonna call that time's up. Making an additional homework that's actually due on the last day of class. No, 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 no. I will do my damnedest to put together some optional, but not for points problems. You want additional problems, there you go. I will also point you, as always, to previous tests and homeworks, as that's where I pull my questions from. Okay, but still, here, I want to give you time to do that one thing, and let's bang this out real fast. 1 radian, about 57.3 degrees. To be precise, it's 180 over pi, exactly. Screw that, you can have 3 sig figs. 1 revolution, 2 pi radians. Defining equation for omega, angular velocity, is change in angle per time, yeah. Theta. This is omega, this is a theta, this is delta. This is pi. They're all Greek letters. You want me to write it out? If you just look up Greek letters, this is all. Yeah, they're the Greek letters that are used here. Okay, so omega, the rate of change of angle instead of the rate of change of position. Velocity, delta x over t? No. I asked you in terms of r and omega. R omega. Period is inverse frequency. When I first introduced this, like everyone, well, most people got it right. You've done period and frequency in your chemistry classes, is that it? Or when? Or you just remember it from high school? Okay, whatever. You know it, that's what I care about. Radians per cycle, cycles per second gives radians per second. Question.
L and O the same.
Yep. Yuppers. Yes. 10. 10 is rotation. 30, 30, 30, 10. Okay, shall we go back to, are you guys okay with those defining equations, and for rotations, I'm keeping it light. It'll be plug in. You know what the terms are and what they mean. And the rotation problems are the easiest ones. You just got to keep track of what does everything mean. Okay, let's do this sucker. The trampoline compresses. Trampoline compresses as you hit it. I mean, kind of duh, right? I will remind you here that we started with what? We started with, well, the total energy at all. The total energy at all we discovered is one form or the other, 195,000. We just discovered that the spring constant K is 173,000. There's another thing. There's another thing. Oh, and the change in length of the spring is what? 1.5 meters? That's everything that you could possibly need here for this, which I'm going to call question Q. To make a stab at this. No, there's one more thing that the 3 o'clock died on. What does it mean to express something in terms of $100 bills? If I got $4,000, how many Benjamins have I got? So I've got $4,000. That's the same thing as 40 Benjamins, right? It's all about the Benjamins. Okay. So what did you do to convert 4,000 to 40? Divided it by dollars per Benjamin. Each $100 bill is $100 worth. So 4,000 divided by the dollar per Benjamin is 40 $100 bills. Likewise, if you find an acceleration in meters per second squared, and you know that g is 9.8 meters per second squared, you can express things in terms of multiples of g. How many times g is, how many times something is compared to g, simply divide by 10, 9.8, whatever. Now this problem does require you to think about what forces are acting on the object when they are at max compression, and to apply the fundamental law of force, which I hope that you remember. I'm going to let you guys wrestle with this for 5 minutes, then I'll work you halfway to it, then I'll let you wrestle another. Great. Please do talk to each other, though. This is more representative of the medium hard end of the test. We've just been practicing fundamentals. Here's something actually like applied. Take 5. And Marie, 3 sig fig should get you enough precision. I mean, if you don't round, it's 173,333.3333333333333333. But I like to round. It's much bigger than that. It is very unsurvivable.
Wait, you want it in G's?
Multiples of your normal compression. Bigger. Okay, again, hint time. What forces act on the dude? What forces act on me in this problem? Not normal. I'm on a trampoline and bouncing. Spring force and weight force. You have an equation for spring force. You have an equation for weight force. Plug them in. If I'm on top of a trampoline, it pushes me upward. Spring force. I've been writing deltas. Please. I'm curious though. Well, and why aren't we? Yeah. Yeah. Hey, here we go. Identify the force or forces. There's a trampoline pushing up on you. I call that a spring force. There's a planet pulling down on you. Duh, I call that a weight force. Which direction does the spring go? Positive. Which direction does weight always pull? Downward negative. So if I write my total force, spring plus negative weight is kx minus mg. I've been saying delta x. K delta x minus mg. What's k? Bam. What's x? Delta x, bam. What's mg? Oh, I didn't write that down. Mg is 650. What's m? 65. If mg is 650, then m had better be 65. Question. That's energy. That's how we found K, is by considering the energy of the system. But now we're applying this to, what am I asking about? I'm asking about accelerations and saying use forces. Spring force. Kx spring force, half kx squared spring energy. Okay, solve this for A, just plug in, you get about 4,000 meters per second squared, which is equivalent to about, I'm rounding, 400 Gs. Is this survivable? No. I mean, for a short period, I think 20. NASA actually published, NASA or the Air Force published a book all about, where do airframes dissolve, where do people say stop the experiment, stuff like that. They probably did cadavers. I don't know. One. This is one. On what? On a roller coaster? Oh, I don't know. Two,
Two.
2, 3, 6, 7. No, much less than 6, 7. Depends on the roller coaster too. Absolutely. I don't actually know for real. I'm making that up, but I would imagine no more than 2 or 3. Okay, pregúntame. Ask me questions. Yes. Because I know that the spring is pushing me up. Because the negative means the force is in the opposite direction that the spring compresses. Which direction is the trampoline compressing? Negative downward says the force is upward. So, I mean, the negative is actually there, it's just the delta x is negative too. Sure, but I encourage you always, when you know the direction of a force, just use the magnitude and consider the direction as your plus or minus sign. If you can intuit it, if you know it, if you can visualize, this force is pointing right, just use the magnitude in the formula. Yeah. Please. We didn't use force equations before. Sure, that's the meaning of work.
External. We don't establish external forces like that. Spring force.
When we do energy land, but there is no potential force land. Yes. We are applying what we learned in one picture, K, and using that in our previous, what we learned in month 2 of the class. Nothing's on A, yeah. Yeah. I didn't subtract. I added a negative quantity. Weight is downward. Gravity pulls downward, right? I call that down the negative direction. So when I'm finding the total force, I'm adding together an up positive and a down negative. Look, which direction do you think gravity is? Yeah, so if I add a downward force, what do I do? This is how I did it. Like, look at any example in second month of your notes. Any example. If I have an upward and a downward, a leftward and a rightward, a forward and a backward, the forward, upward, and rightward forces have a plus sign on them in F equals ma. The downward, leftward, backward forces have a minus sign on them in F equals ma. This is what I mean by net force. You still don't like it. Why is what included? When you're standing, when you're being sprung by the spring, what forces act on you? Yeah. Spring and the earth force. And what is the force that the earth exerts? It's your weight. Yeah. Good. Okay. Last chance. Please. What? G's. Multiples of gravitational field. Which is to say, yeah. Yeah. I mean, it's not actually 4,000 either. Like 3920 or something. How many multiples of, which is ultimately, what does it feel like? It feels like you're standing on a planet with 400 times the gravity. That's the meaning of G's. Okay. If you wish, here's one last one. No, not if you wish. This takes like 2 seconds. and this should help with the idea of conservation of energy. Do this, I'll present the answer, and you are free. Well, kinetic energy is a force, other than the gravitational potential. Gravity, other than weight. What would you include on the right side of the central equation? External work is what I'm looking for. Okay, what's my initial? 20,000 plus 10,000 is 30,000. What's my final energy? So what's my change in energy? Not this problem. By
What?
Well, ask. Where'd you get stuck? Where'd you?
Well, I was thinking about, well, you said it'd take 2 minutes, we did pretty fast, but my first thought process was plugging into something, and then I realized it's not gonna work hard. Alright, like it'd be hard to plug into something, and then I realized all you gotta do is basically do that, it's just.
Good.
Just. And I was like, going to each one of these one, but I was like, wait a minute, it's not even slide it. If that makes sense.
Hold on. Everybody else is going. So I'm gonna give my dispensation. Here's a papal dispensation or papal dispensation because I'm Papa. Get out of here. I love you all. See you on the exam day. But or if you're in my lab section, come tomorrow. Bye. Now, please ask.